Welcome to TapRen Tech Solutions. Today, we're breaking down FCC certification for PCBAs, why it matters, what it involves, and how to get it right. If you're building IoT devices, wireless modules, or high-speed electronics for the US market, this is your roadmap to compliance. FCC certification is a regulatory compliance mechanism mandated by the US Federal Communications Commission. It ensures that your printed circuit board assembly doesn't emit harmful RF interference and operates safely within defined EMC limits. Whether you're building wireless modules, IoT devices, or high-speed digital circuits, obtaining FCC certification is essential to legally sell products in the US, avoid costly recalls, bans, or penalties, build customer trust by ensuring quality and safety. FCC rules that affect PCBAs are primarily under Parts 15 and 18. Part 15 covers unlicensed RF devices like Wi-Fi, Bluetooth, and Zigbee modules. It focuses on emission limits for consumer and communication devices. Part 18 applies to industrial, scientific, and medical ISM equipment, such as microwave-based or plasma-generating devices. Understanding which category your PCBA falls under is the first step towards selecting the right compliance path. Passing FCC testing starts at the design stage. Here's how to make your PCBA ready for certification. Ground plane integrity: maintain solid ground planes to reduce noise and emissions. RF shielding: use metal shielding cans over RF modules or high-frequency circuits. Controlled impedance traces: route high-speed signals carefully to prevent unintended RF radiation. Decoupling capacitors: place capacitors near power pins to suppress high-frequency noise. Loop area reduction: minimize loop sizes in high-speed circuits to cut down emissions. Optimize layer stack-up: configure layers to shield noisy components effectively. There are three primary authorization pathways. 1. FCC certification, FCC ID, for PCBAs with intentional RF emitters, for example Wi-Fi, Bluetooth, requires testing at an FCC-approved lab and a unique FCC ID. 2. Declaration of Conformity (DOC), for digital devices without intentional RF transmitters, but with possible EMI. Manufacturers self-declare compliance while keeping test records. 3. Verification, for embedded or internal components not sold directly to consumers, requires testing and documentation but no FCC ID. Here's how to get FCC certification for your PCBA step by step. 1. Device classification: determine whether your board emits RF signals. 2. Pre-compliance testing: detect and fix issues early with in-house or third-party tests. 3. Select an accredited lab. Work with an FCC-recognized lab for official testing. 4. Prepare documentation. Collect schematics, layouts, BOMs, photos, and test reports. 5. Submit to a TCB. A telecommunication certification body reviews your application and issues your FCC ID. 6. Label and market. Add the FCC label and start selling your compliant product in the US. FCC testing ensures your board meets strict EMC and RF requirements. Key tests include radiated emissions: measures RF energy emitted into the air. Conducted emissions: checks noise through power data lines. Spurious emissions: ensures no out-of-band interference. SAR testing: for wearable or handheld devices near the human body. Power and frequency stability: confirms correct transmission levels. FCC certification typically costs $4,000 to $18,000 and takes 4 to 8 weeks, depending on complexity. Failing to comply? You risk fines up to $100,000 per violation per day, product recalls or import bans, brand reputation damage, and market access loss. It's far cheaper and safer to design with compliance in mind from day one. FCC certification isn't just a checkbox, it's your ticket to the US market. By designing with compliance in mind, testing early, and working with the right partners, your PCBA can meet FCC requirements on time and within budget. At TapRen Tech Solutions, we help clients navigate FCC certification from design to approval. Let's get your product market ready.